So we have seen the model view presenter. By implementing this pattern, we were able to enhance the application code by establishing a three-tier architecture that effectively separates the different types of code within the application. And using this approach, the React components are now simply responsible for rendering the markup and no longer contains any business logic. Today, we will see how to apply design principle and patterns to establish a three-tier UI architecture in React to develop applications that are clean, maintainable, testable, and scalable. But before, have you ever noticed when you pass by the closet and spot the vacuum cleaner code coming out? Each day, as we walk by, we kick the plug to put it back and swiftly close the door. And after 10 days of repetition, we have transformed it into professional plug kickers and requiring only a single kick to restore its place. Now, imagine how much better it would be if instead of investing our time perfecting a wrong approach, basically, we paused to take a correct action that could resolve this situation. For instance, reorganizing the vacuum cleaner within the confines of the closet. In the past few years, I found myself repeating the same pattern while managing React project I worked on. There was always something amiss, something that required fixes, but my attention was consistently drawn to the wrong aspect, the frameworks, the library, and stuff like this, until one day I made the conscious decision to pause and delve into the root of the problem. And now I would like to share with you what I found out about it. You see, you don't want your React code to look like the cluttered closet on the left. Instead, we aspire to halt our progress temporarily and dedicated a day or two maybe to organizing it so that we can reveal the newfound order. Okay, so something about React. As developers, it is crucial for us to maintain a healthy level of skepticism about frameworks. Because after all, they all originate from the same premise, that is resolving the imperfection of the previous one. And they often assert the same argument, their approach is the best one. Back in 2014, the React team wanted to enhance the previous version of web frameworks by introducing the concept of closure and scope directly within components through the use of JSX and the virtual DOM. And they claim that this approach would yield a cleaner API, enabling views to be fully responsive and capable of adapting to changes using the virtual DOM. And this enables developers to adopt a declarative programming model rather than specifying the step-by-step instruction using imperative programming. And by adopting a declarative paradigm, React aims to establish a clear separation of concern, ensuring that views and logic operates independently. And this is achieved by segregating behaviors and data, enabling a more modular and maintainable code. Unfortunately, what I frequently see is that we tend to take a piece of markup code, combine it with random business logic, and insert into a React component, resulting in a jumbled mixture. And consequently, when requested by the marketing team to modify a feature, we often find ourselves struggling with the complexity of our code and eventually get frustrated. I think this is something that most, if not all, developers have experienced, don't know. And in fact, I dare to issue a challenge to anyone who believes that have never faced this problem. Let's say you begin developing a browser-based chess game, you create an application that look like this, and after a while, Rosie from the marketing team approaches you with some new demands to develop a 3D version of the game, and shortly after an augmented reality adaptation. And she may expect that transition into a 3D or augmented reality version of this chess game would be as simple as changing the UI. However, the reality is often far from easy. The challenge lies in the fact that our application often lack a clear separation between the UI and the business logic. Can someone relate to this? Yeah, okay. And what I'm trying to say is that, as stated on its website, React is a JavaScript library for building user interfaces. However, unfortunately, it is often used for purposes beyond its intended scope. And this led to the development of applications that are to test, to maintain, and scale. So now a little bit about me. My name is Lorenzo Spinelli. I work as a developer for Register.it, and additionally, I'm the co-founder of the Firenze Dev community. That is a community of developers where we have fun and grow together through discussion and collaboration. We organize free events for programmers in Florence, providing tools and support to continuously learn and improve. I also serve as an advocate for the Polygon blockchain. I cannot stand by to hear the talk from Mirko and Umberto. These are my contacts. Feel free to reach out using these contacts. I'll be happy to answer any question or respond to your comments. So let's move on the main topics. I'd like to present you with this application, a classic to-do list app. Upon logging, the application loads a pre-existing list from an API. From there, you have the option to add new to-do items or log out. I know it's nothing exceptionally fascinating or fancy. It's just your typical average to-do app. Now, I invite you to imagine the underlying code of this application. For example, the React component that renders the list of to-dos may resemble something like this. Between line 10 and 12, the component utilizes a state to store the to-do items, potential errors, and the loading state. The to-do state is retrieved, use the load to-dos function, defined on line 14, and after the initial render on line 27, the load to-do function is invoked to fetch the necessary data. Ultimately, the components display either the list of to-dos or any encounter errors based on the retrieved state. And in essence, this code performs the following task. It is managing the state, it is fetching data from an API, and we call this business logic, and it's handling the visualization aspect. And this precisely highlights the issue I mentioned earlier regarding the lack of separation of concern. All these different responsibilities have been mixed within a single React component. And the absence of clear boundaries between this concern hampers the ability to effectively isolate and test individual components. And it also restricts the flexibility to modify or extend specific functionalities without affecting the entire code base. And in terms of scalability and reusability, the tight coupled nature of this code make it less adaptable to change or reuse in other contexts. So I've mentioned the term separation of concern several times. Let's see what it is. It is a design principle that advocates for dividing a computer program into distinct sections, and with each section dedicated to addressing a specific concern or a particular set of information that influences the code. Now, armed with this understanding, let's explore how we can enhance this existing code by applying the principle of separation of concern. we can begin by identifying the distinct concern and responsibility within the component and extracting them out. I have identified the three concerns. The first is calling an API, the second is loading the to-do list, and the third is building the markup. Let's start off with addressing the first concern. So our initial step is to extract the code responsible for API calls from the component and thereby segregating this specific functionality. For instance, we can create a separated class and call it to-do store that will be responsible for handling the retrieval of to-dos. And I saw your faces when you see the class, don't worry. So by doing so, we effectively isolate the logic related to fetching the to-do data from the components itself. And the to-do store class will maintain the state of the to-dos by saving them in a dedicated field, as seen on line 6. And additionally, it includes a load to-do method on line 13, responsible for calling the to-dos APIs. And once we have successfully separated the concern of managing the to-dos, the next step is to establish a connection between this code and the component code. To do so, we can use the to-do store class on line 15 to load the to-do items by invoking its method load to-dos. And next, on line 28, the components renders the retrieved to-do items by reading the data from the to-dos field and displaying them accordingly. So, have you noticed something strange in this code? Maybe. By performing this refactoring and separating the concern, the application no longer functions as expected. This is because when the to-do items change within the to-do store class, React is not aware of these changes and consequently don't update or display them in the component. And to address this issue, we need to establish a connection between the to-do store and the to-do store class and React, ensuring that React is notified of any state changes in the to-do store class. So how do we connect the class to React? We can leverage the observer pattern, that is a software design pattern which states the observer pattern. In the observer pattern, an object known as the observable or subject keeps tracks of a collection of its dependents called observers. And the subject, the observable, automatically notifies the observer of any state changes. In this scenario, we have an object known as an observable, and the observable grants certain observers the capability to subscribe to its state changes. That means whenever there is a change in the state of the observable, it proceeds to notify all of its observers. What we aim to achieve is to designate the to-do store class as an observable and the React component as an observer. By doing so, when there is a change in the state of the to-do store class, specifically the to-do items, the React component is notified. As a result, the component can update its rendering and to reflect the updated list of to-dos. Now, several libraries for state management in React have implemented the observer pattern, and some of the most popular ones include Redux, State, Recoil, State, Jutai, Zustand, and Mobix. And in this particular example, I will be using Mobix as the state management library. The reason behind this choice is that Mobix aligns well with working with classes, making it a suitable option for our implementation, and closely adheres to the observer pattern in its naming convention and functionalities. I want to emphasize that my selection of Mobix is not a statement claiming it to be the superior choice. It's just a practical decision to explain a concept. So at a code level, the modifications are minimal. We introduce the makeObservable statement within the constructor of the class on line 9, and this statement is used to enable observability for the class. To the makeObservable make observable function, we provide an object containing the to-do property, and this indicates that the to-do field is made observable, allowing to be observed for change, and we are at line 10. And now that we have established an observable, we require an observer, which in this case is the React to-do list component. That we encapsulate in the observer function, and by doing so the component becomes an observer of the observable state, and the observer function enables the component to trigger a re-render whenever there are changes in the observed state. That means once the to-do items are loaded into the class, the component automatically renders. As a result, the to-dos are displayed on the screen, reflecting the updated state. And this was the separation of concern part. We have seen how code quality can be enhanced by employing the principle of separation of concern and the observer pattern. By separating the management of to-dos, that is the business logic, into a dedicated class, we have achieved a more organized and maintainable code base, a more modular code base. And we are quite satisfied with the progress we have made so far, but there is still room for improvement in our code. Let's take a closer look at the to-do list component, which is responsible for displaying the list of to-dos. In the aligned section of code, the orange box, we can observe that it goes beyond the task of constructing the markup. Instead, it handled several additional responsibilities. The first is managing the loading state, handling any potential error, implementing the logic of loading the to-dos, and it also requires knowledge about how and where the to-do items should be loaded, and it is the use effect hook on line 24. And while this code successfully accomplishes this task, it introduces a level of complexity that the component is forced to handle. And I cannot stress enough the importance of adhering to the fundamental principle that React is primarily a library for building user interface, and that the biggest problem with markup and views is making them too smart. And it is crucial for us to avoid overload React with uncontrolled business logic, even when it pertains to data presentation. So instead of pushing React to perform tasks outside its design scope, we should force it to do what it's great at, that is building user interfaces. And to achieve this, we can rely on another design pattern, that is the model view presenter. And it is a variation of the model view controller architectural pattern, mostly used for building user interfaces. And in this pattern, the presenter assumes the role of an intermediary or middleman, and it's responsible for handling all the presentation logic. Moreover, by implementing this pattern, we can establish three distinct layers within the application, and also establish clear boundaries in the code based on its type within each layer. And what are these type of code? The first category of code is the business logic, and these including data transfer object, business object, entities, function, and transformation. Another category involves the code responsible for building the views, which reside within the React components. And this encloses everything related to markup, buttons, validation, browser events, and other aspects of the user interface. And lastly, we come to the third category of code. This particular one must have some knowledge about the business logic as well as the view. And we can refer to it as the view abstraction. Imagine it like a bridge connecting the view and the underlying business logic. And these three types of code form the layers of an application. And these three layers are what composes the model view presented pattern, and we should keep a lot of attention in not mixing these three layers. Now, let's implement the model view presenter pattern in React. We already have completed 2 out of 3 layers. We just need to extract the business logic from the component and transfer it to the presenter. And afterward, we'll establish a communication channel between them. Let's see how to accomplish this. The presenter, but first, I want to say that the presenter is responsible for creating the view model. This view model is a flat data structure that contains all the information for the components to build the markup. And it should exclude any details about the intricate business logic used to generate that views. What I mean by this is you don't want to fill the view model, this object, this very simple object, with the data coming from an API, or generally speaking from the business logic. Instead, the view model should be as flat as possible and contains just what is needed for building the markup. And the presenter role is to create and pass the view model to the component. And so with this concept in mind, let's see how we can implement the code for a presenter and a view model. So we can start again creating another class. I call it the to-do list presenter class, and this class will serve as an observable, maintain its own state and notifying observer of any updates. On line 24, we have a method to expose this view model, that is this flattened data structure containing to-do list, error information, and the loading state. And additionally, on line 28, we have a method for creating the view model by utilizing the load function from the to-do store class, the other class. Now, our task is to integrate the view model into the React component. And one approach is creating a custom hook. This hook would take, for instance, would take this is called use model, and it takes an instance of the presenter as an input, and it utilizes an use effect to load the view model data. You see, inside the use effect, we define the async function bootstrap that calls the load view model method on the presenter to load the view model. And last, the hooks returns the view model, allowing the component that utilizes it to access and utilize the returned value. By the way, we use a custom hook because it's reusable. We can use the same hook with all the presenters in our code base as long as they adhere to the same signature. So they have load view model and an object view model. And lastly, we can utilize the created hook in our component. At line 57, we invoke the view model hook by providing the presenter as an argument. And then we can utilize the data provided by the view model. And the to-dos on line 62, yeah, and the error and loading state at line 67 and 68. Now our component is significantly simplified, devoid of any business logic. So we have seen the model view presenter. By implementing this pattern, we were able to enhance the application code by establishing a three-tier architecture that effectively separates the different types of code within the application. And using this approach, the React components are now simply responsible for rendering the markup and no longer contains any business logic. If we consider where we started from, I would say this is a satisfactory result. We have made remarkable improvements. However, it's possible to further enhance our code. Let's see how. There are a couple of aspects in this component that I find undesirable. And the first is the instantiation of the presenter within the component's code. And this approach doesn't provide any segregation of the three layers as intended. And the second, it would be more desirable to work with abstraction rather than concrete implementations. And by relying on specific implementation like the to-do list presenter, the code becomes tightly coupled, which can hamper maintainability and flexibility. Once again, we can rely on a programming principle to assist us, and this is the dependency inversion principle. And this principle provides a specific approach for creating loosely coupled software modules, and it states that high-level modules should not directly depend on low-level modules. Instead, both should depend on abstraction, such as interfaces, and abstraction should not rely on implementation details. Rather, the details should depend on the abstraction. Translated, rather than saying, I need the ABC class, we should say, I want something that implements the ABC interface. By depending on interfaces, we achieve flexibility and loosely coupling between components. And this leads us to the final important topic we should grasp to write scalable and maintainable application, that is inversion of control. If you are familiar in software development techniques, you might have come across the terms dependency injection and inversion of control. So let's explore this concept using JavaScript in a simple and understandable way. Dependency injection is a programming technique where classes or functions receive their dependency from an external source instead of creating them internally. In this simple example, when using dependency injection, we can specify the interface that the lamp class should use for its bulb. On the other hand, without dependency injection, the lamp class would be pre-configured with a specific type of bulb, in this example, the Philips one, and that cannot be changed. And finally, we have inversion of control. Inversion of control is a programming principle that involves reversing the flow of control in an application. Typically, in a procedural programming, application code calls library procedures to perform tasks, thereby passing control to the library. In contrast with IOC, with the inversion of control, an application level component retrieves control from a reusable library component. I see your faces. Translated, it means an IOC containers allow us to replace the first code block with the second one. In the second example, we utilize an IOC container to retrieve the required dependency by passing a token, in this case, the dependency. And by leveraging the container, we eliminate the explicit inclusion of the dependency in the source code, and instead delegate its retrieval in the container, from the container at runtime. So what we want to do in our project is to create an IOC container and add all the dependency to be injected at runtime into it. Next, we want to use the container in components, hook and classes to retrieve dependencies at runtime. Do you remember the code that we didn't like? We would like to replace it with something like this, where dependencies.to-do-list presenter represents a token or an identifier for the to-do list presenter dependency, which we retrieve from the IOC container. To do this, we need to find a way to inject the container into the useModel hook and retrieve the required dependency from the container. Let's see how to do it. React provides us the context API, which allows to pass information between components in the components tree without the needs for props. So the first step is to create a React context. Next, we create an inversion of control container. Imagine it like a key value map where we can store objects. We add the dependency to the container, assigning them a unique identifier that we'll later use to retrieve them. So in this example, we put the token string or the token identifier, and we put into the container the presenter. an instance of the presenter. Next, we set the IOC container as the value of the context, and we wrap our application within the context provider. So basically, we made the container available in the whole app. At this point, in the use model hook, instead of passing an instance of the presenter as the input, we pass a token to retrieve the dependency from the container. And to access the container, we use the use context hook from React, passing the IOC context. And once we have the container, we can simply retrieve the desired dependency from it using the token. So this function has a token, the identifier of the dependencies, and we retrieve it from the container. Finally, in the to-do list component, we can use the use model hook, passing it the token related to the dependency of to-do list presenter. So we have achieved a DAM component that is clean, easy testable, maintainable, and in terms of code, it only focuses on one thing, that is displaying the to-dos, and it doesn't have any business logic and depends on an abstraction, that is the hook. So, final thoughts. By applying the right principle, the right design principle and pattern, we have seen that our code become cleaner and more maintainable, and our application become more scalable and testable. And we began by adopting the observer pattern, which helped us to achieve a clear separation of concern in our code. Next, we implemented the model view presented pattern, which allowed to establish a well-defined architecture with 3 distinct layers. And this architecture enabled us to clearly delineate the responsibilities of each component, of each modules in our code base. And finally, to handle dependency injection, we leverage the power of inversion of control. So I want to emphasize that the purpose of this talk goes beyond simply applying patterns to code. It aims to inspire us to improve and optimize the code we write. Because when you venture into the real world, you will encounter difficulties applying this concept. The example and the refactoring I did during this presentation were purposely simple and tailored for the talk. And you may be tempted to take the fast route to write any business logic in the component, but ask yourself, if I save time now, will it also result in 3 times the time savings a year from now, when the project grows larger? Because I think programming always involves making compromises, but remember that you must decide the architecture of your application and not suffering the one imposed by frameworks or libraries. So, some resources using this QR code, you can find the following. The first is the code of the to-do application with each branch featuring a refactoring step we have seen. And the second is a library emerged while preparing this presentation. If you apply these patterns, you will write hooks, configuration, and function that you will need to duplicate in the future project. And you can try using, instead of duplicating the code, I created this library that is designated to facilitate code reuse. And it's still a prototype, but if you feel up to it, you can try it and let me know your thoughts. And finally, the last is the link to the slides. So, whatever method you want to use, give it a try, you will enjoy it. And that's all. Thank you very much.